Welcome to AIDS Treatment and Technology. Today we're just going to do a little informational blog about how HIV works and how that is the basis of all of the future AIDS treatment and technology. So here we are. We got humans. It's a sunny day. We're happy. But there's things all in our environment that are trying to get in our bodies and tear us apart, resulting in our death. One of these things is HIV. HIV is a virus. Viruses work by getting in the body, infiltrating cells, using them as host cells to replicate themselves, and then further possessing more cells in the body, resulting in the destruction of those cells. Normally in the body, we have macrophages and T cells. These two cells are kind of like the defense guys. They put up a big wall. This wall is large and in charge. Very hard to get through. HIV, though, circumvents this. It can sneak right under the wall, attack these two cell types, and wipe them off the face of the planet for good. So then, how do we stop this enemy? Well, we need to look at its life cycle. We need to read about it. We need to know about it, and we need to know it. Because to know your enemy is to defeat your enemy. The best defense is an offense. So what we're going to do is dissect the HIV life cycle and see where we can attack it. So, what is the HIV life cycle? Well, let me tell you. In HIV and viruses in general, focus on the three main steps that current treatments and technologies are being developed against, and we're going to replicate itself by the tenfolds, by the millionfolds, and make enough virus to overtake the entire body's systems. Lastly, we're going to talk about assembly. After these viruses have overtaken the cells and replicated them, how do they get back out into the circulation and continue to infect and afflict the body? These are all very key points, but these three are the most important and what we're going to focus on. So first, let's go to attachment. Here we have the basic attachment of the HIV virus and a T cell. Now, in the attachment of HIV with T cells or macrophages, there are certain key elements that we have to focus on. These are the cell surface receptors, and really there's different classes between each of the cell types, so we're not going to focus on the names. The important thing to know is we have two receptors, as you can see here by the pink and the green, and the HIV has two receptors, perfect matches. Once again, these names for the HIV receptors, not important. The important thing to know is HIV can recognize these cells through these receptors, and by that, after recognition, they throw themselves inside the T cell, populate the T cells, and take them over. So after recognition, HIV ends up inhabiting the inside of the cell. So how do we get to this point? By attachment. So the main point of the attachment phase is the HIV receptors recognizing the T cell receptors. So when we're looking at treatments, specifically drug treatments, how can we stop this recognition? Well, one thing we can do, let's blanket these receptors and let's hide them. Because if HIV can't find them, it can't infect them. This type of drug is called Fusions. These drugs are going to work by basically putting a big cap over these receptors. This big cap completely hides the receptors, and HIV now can no longer come in and bind. It stopped right at the point of recognition. The second point in the life cycle that we want to focus on is replication. So let's move down there. Here, as you can see, we already have HIV inhabiting this T cell, so that's a problem. The attachment phase was unsuccessful. So now we have HIV inside the cell. What what it's going to do is it's going to take the cell's natural cell machinery and it's going to reproduce itself and multiply itself so it can just keep taking over the body. Replication is the process of the HIV DNA taking the cell machinery, producing its own RNA off of our cells, and then by producing its own RNA, further using our own cells to produce itself in mass quantities. So, looking at this step, how can we stop this? Well, there's really one key point where we do this. The types of drugs that do this are called NRTIs and NTRTIs. Once again, it's not about the big names here. This is purely an educational video to show you how we can stop HIV. How do these drugs work, though? What happens is we're gonna demonstrate the drug with a D. After taking the drug, as the cell machinery is coming in, grab on the HIV DNA and reproduce it, the drug is going to be there to be used as one of the parts of synthesis. When the cell machinery is coming in and sees this drug, instead of saying, hey, keep replicating, the drug says, enough, we're done. Stops the cell machinery right in its tracks, and that's the end of synthesis, thus blocking all replication of the HIV and keeping the viral content inside the T cells from growing. The third point in the life cycle that we were looking at is now assembly. So let's move down there. Here we have one of the last steps in the HIV life cycle. After already taking over the cell's machinery, reproducing itself, now it needs to be broken up and back into its individual viral particles to be spontaneously organized and extruded from the T cell and to further infect other defense mechanisms of our body. One way it does this is through a viral protein called protease. These proteases are going to come in to the polypeptide viral chain and break it apart into each of the viral protein components. So, how can we break apart and stop this assembly portion of the life cycle? Well, we need to stop the protease from being able to get to here. The class of drugs that do this are called protease inhibitors. Or as we'll refer to them, just PI. What PI is going to do, it's going to come in. And these drugs are going to work by creating a defense wall around the viral proteins. What this does is now these proteases can't get through. They can't chop this up. Without the polypeptide chopped up, we can't have the viral particles combining. They can't be secreted out of the T cell. Thus, no other cells can be infected. So really what this does is just set up an extra barrier to stop the viral action. So we've gone through three main mechanisms here. We've looked at three of the points in the life cycle: attachment, replication, and assembly. We looked at three classes of drugs that can be used as treatments against these: fusions, NRTIs and NTRTIs, and PIs. In summary, what we've done here is, instead of just looking at HIV as an undefeatable enemy, we've dissected our enemy. We've studied our enemy, we know its weak spots, and we know how we can attack it. These are just three of a plethora of many drugs that are useful against HIV/AIDS. And as future treatments and technology, more and more researchers are looking at every step of the HIV viral life cycle and figuring out new ways we can attack each of those steps to further increase our effectiveness against stopping HIV.